Hey friends, welcome back to Math Defined. Today we're reviewing surface area and volume of prisms, cylinders, and pyramids, and identifying cross-sections of 3D figures. This is a big picture review. Here's how this is going to work. I'll explain the setup, and then I want you to pause the video, solve it on your own, and then come back and check your work with me. If you need more help on any of the review topics here today, I have linked the specific videos for each lesson in the top right-hand corner of your screen. I have also included the links for each review topic in the description below. No pressure, this is practice, not perfection. So, let's get started. Let's start with surface area of prisms. Remember, surface area is like wrapping a present. It includes every outside face of the solid, top, bottom, and all the sides. A prism has two congruent bases with rectangular faces wrapping around the sides. The formula we use is surface area equals 2 times the area of the base plus the perimeter of the base times the height of the prism. Take a look at this rectangular prism. Before I do anything, pause the video and solve it on your own using the given dimensions. All right, let's check it together. The base is a rectangle, 2 times 3 is 6, and we have 2 bases, so that's 2 times 6 to get 12. Now for the perimeter of the base, 2 plus 3 plus 2 plus 3 is 10. We can't forget to multiply the height of the prism 5 feet to the perimeter of the base. 10 times 5 is 50. Adding everything together, 12 plus 50 is 62. So the surface area is 62 feet squared. Nice work. This time we have a prism with a triangular base. Same formula, just a different base. Go ahead and pause and solve this one on your own. Okay, now let's walk through it. The base is a triangle, so we use 1/2 times the base times the height. We'll simplify the fraction 1/2 with 16 first, and then multiply to get 48. And then we double it because there are 2 bases. 2 times 48 is 96. Now we'll find the perimeter of the triangular base and multiply by the height of the prism to get 324. When we add everything together, we get a total surface area of 420 meters squared. Don't forget, if you need a little extra help, just click the link above. Now let's move into cylinders. Remember, the formula structure stays the same, but the base is a circle. So the formula becomes 2 times pi times the radius squared to find the area of the 2 bases. But don't confuse the diameter here with the radius. The radius is 1/2 the length of the diameter. Then we add pi times diameter for the perimeter, or the circumference of the base, times the height of the cylinder. Now take a moment to pause and solve on your own. All right, here's the breakdown. First, find the area of the 2 bases. 3 squared times pi is 9 pi, and 2 times 9 pi is 18 pi. Now add the circumference of the base multiplied by the cylinder's height. 6 times 12 is 72, and 72 times pi is 72 pi. Adding them together is 90 pi, or about 282.6 centimeters squared. Let's keep this review going, but before we do, I'm going to ask you to click that like button. It really goes a long way in supporting our channel to help viewers just like you. Here's another cylinder. Same steps, just new numbers. Pause and solve on your own. All right, let's check your work. The surface area of the two bases is found by multiplying pi times the radius squared times 2. 6 squared times pi is 36 pi. Times 2 is 72 pi. Now add the circumference of the base times the height of the cylinder. 12 times 7 is 84, times pi is 84 pi. Adding 72 pi and 84 pi gives us 156 pi, or about 489.8 feet squared. You're doing great, but let's keep it going. Pyramids are a little different. Instead of one formula, we think in parts. The first part is to find the area of the base. The second part is finding the areas of all the lateral faces or sides of the pyramid and add this to the area of the base. Go ahead, pause, and solve. All right, the base of this pyramid is a square. To find its area, we'll multiply length times width. The lateral faces, or sides of all pyramids, are triangles. To find their areas, we'll multiply 1/2 times the base times the slant height of the triangle times 4, which is the number of lateral faces. It's nice to simplify the fraction before we multiply. Now we just add them together, and the surface area is 144 feet squared. That wasn't too bad, just a lot of calculations. All right, last pyramid example. Same formula as before, but with a triangular base, which means it has 3 lateral faces. Go ahead, pause, and solve. Okay, first the area of the base. 1/2 times 9 times 7.8. It doesn't really help us this time to simplify the fraction first, so we'll multiply 9 and 7.8 to get 70.2, and then 1/2 of 70.2 is 35.1. Now for the areas of the 3 lateral faces. This time you can easily simplify the fraction before you multiply, and 9 times 5 times 3 is 135. One last step to find the surface area. 35.1 plus 135 is 170.1 yards squared. Now let's switch gears to volume. Volume tells us how much space is inside a solid. The formula is area of the base times the height of the solid. We'll use this bottom rectangle as the base for this rectangular prism. Now it's your turn. Pause and solve. All right, first find the area of the base by multiplying length times width. And then the height of the prism is 6 inches. Multiplying these dimensions, we get a volume of 96 inches cubed. One nice thing about finding volume is that there are way fewer calculations than finding surface area. Wouldn't you agree? Pause and solve this one. Be careful, the base of this prism is not a rectangle. Okay, are you ready to check your work? First, find the area of the triangular base. 1/2 times the base times the height of the triangle, and then multiply it by the height of the prism, 8 meters. Now we just multiply. First, we'll simplify 1/2 and 4, and then multiplying the remaining dimensions, we get a volume of 120 meters cubed. Nice work. Next up is volume of pyramids. The volume is the same as with prisms, but with one big difference. The volume of a pyramid is 1/3 the volume of a prism. So the formula is 1/3 times the area of the base times the height of the pyramid. That 1/3 is the key difference between pyramids and prisms. Take a look at this pyramid. Identify the base, then find the height of the pyramid. Remember, the height goes straight down from the top of the pyramid or its apex to the base, not along the slanted edge. Go ahead, pause and solve this one on your own. Are you ready to check your work? First, find the area of the square base, 8 times 8. Multiply it by 1/3, and then multiply by the height of the pyramid, 9 millimeters. We can simplify 1/3 and 9 to make the math easier. Now, 8 times 8 times 3 is 192 millimeters cubed. Super easy when you know what formula to use. Let's try one more pyramid. Take a close look at the base. Do you see that the area of the base is given in the diagram? Nice. Go ahead, pause, and solve. All right, one last check. The base was given, so we have 1/3 times 63, and the height of the pyramid is 12 meters. Millimeters. Simplifying the fraction with 12 gives us 63 times 4. So the volume of this pyramid is 252 millimeters cubed. Now let's review cross-sections. A cross-section is the 2D shape formed when a 3D figure is sliced. Look at each solid and the direction of the cut. Ask yourself, is the cut parallel to the base, or is it cut vertical to the base? Based on the direction of the cut, identify the shape of each cross-section. Pause the video and name each cross-section before checking the answers. The first rectangular prism is sliced vertically to its base, so the cross-section is a rectangle. The middle triangular prism is sliced parallel to its base, so the cross-section is a triangle. And the last triangular prism is sliced vertically to its base, so the cross-section is a rectangle. Do you notice a pattern regarding the direction of the cut? Now let's focus on cylinders. The first cylinder is sliced vertical to its base, creating a rectangle. The second cylinder is sliced parallel to its base, creating a circle. Do you see the pattern again? Let's finish up with cones. The first cone is sliced parallel to its base, creating a circle. The second cone is sliced vertically to its base, creating a triangle. The shape of any cross-section depends entirely on how the 3D figure is sliced. But there is a pattern. A parallel slice results in a cross-section in the shape of the solid's base. Pretty cool. Well, that wraps up our review. You reviewed surface area and volume of prisms, cylinders, and pyramids, along with identifying cross-sections of 3D figures. If something felt shaky, now you know exactly what to study and which of my videos you should go back to and review before the test. Good luck, and I have confidence in you that you can do this. Thanks for watching, and please take a moment to help support Math Defined. Smash the like, hit subscribe, it's free, and helps you keep up with new lessons. I'll see you soon, and as always, keep math awesome.